In this video, we're going to take a look at solving a quadratic equation by the method of completing the square. Quite often, we can't use the method of factoring to solve a quadratic equation, so we must have a second method, and this one is called completing the square. And so think about the special products that we talked about earlier on in the lessons in Chapter 6, and we had this special product of x plus y all squared expands into x squared plus 2xy plus y squared. And very similarly, x minus y all squared expands into x squared minus 2xy plus y squared. So we use this really nice pattern called a perfect square trinomial. That's what this one is, a perfect square trinomial. And we use it, we try to create it, and then we complete the square. So we're going to create the perfect square trinomial, which will then translate into something like this one. And we'll see as we go. Now it helps us to not use a y squared in there and maybe use a d and relate it to the coefficient here of x. So that's what we are doing here in this next line. It's a very similar pattern as you can see, but we've changed the y into a d, which makes it more of a numerical value, because often we think of y's as another variable. So if you notice right here, the value that's getting squared is d, and that d is half of the coefficient of x, right? Because if I divide this value by 2, if I take my 2d and divide it by 2, I get d. All right? That's a pattern we will use consistently throughout this process, taking the coefficient of x, dividing it by 2, and it's the value that gets it's squared and then added to form our perfect square trinomial, and exactly the same when it is x minus d all squared. So let's take a look at an example. Now the very first thing that is essential that we check before we use the method of completing the square is that we have a coefficient of 1 at the leading term, and we do in this case, but it really is essential to always check that. And if you don't have a 1, then you must divide it out from each of your terms, okay? And later on, I've got an example that shows that. So I'm trying to create a perfect square trinomial, and I've got 2 terms here to begin with. We will reuse these first 2 terms in our perfect square trinomial. However, the d squared that we add to that on the end is not going to be the 11 because that doesn't work. So let me just rewrite this. The negative 11 is going to get moved over to the other side of the equation. And I'm going to write it as x squared plus 4x. I'm actually going to leave a little space. Negative 11 when moved over becomes positive 11. All right, there is our very same equation as we have above. But I'm looking for what gets squared and then added to both sides. And remember what that is? It is half of this value because d gets squared 2d. So this value is equal to 2d. 4 is equal to 2d. Therefore, d is 4 over 2, so d is equal to 2. So we will add, and I'm going to write it this way, just 4 over 2, and it gets squared, just for now, okay? And actually, let's write that in blue so we see it happening to both sides. And we're going to do it here too. All right, so the pattern is take this number, divide it by 2, square it, add it to both sides, always. And let's just simplify that now. X squared plus 4x plus 4 over 2 is 2. It gets squared. You'll see why in a minute why I'm not going to actually write that as a 4 right now. I will on this side. we're looking for the d, right? The d that gets squared, and it's 2 that gets squared. So our d in this case is 2. So when we form this into the square, it becomes x plus 2 all squared, that's this part of it, equals 15. And that's a significant part to get to, okay? So the pattern, I've just followed the pattern as above, reversing the perfect square trinomial into the square of x plus 2. Now remember, we are trying to solve for x. And right now, a lot is happening to x. X has a plus 2 on it, and then it's all getting squared. So we need to square root our x plus 2 squared. And we will square root our 15, and actually plus or minus because there are 2 roots for the square root of 15. My left side then just simplifies to x plus 2, and the right side is plus or minus root 15. All we need to do now is move the 2 over to the other side, and it becomes x equals negative 2 plus or minus root 15. And we have our roots. We have x equals negative 2 plus root 15, and x equals negative 2 minus root 15. And those are the roots. Let's do a second example. And if you had followed the pattern that I said before, you could possibly pause the video and give this one a try. If not, follow through again with me. We are checking for leading coefficient 1, which we have, so no need to do any division first. I'm going to use the first 2 terms as the first 2 terms of my perfect square trinomial. And I'm moving my 4 to the other side of the equal sign. Now I decide. Right here, I have to do 10 over 2. And it's actually negative 10 over 2, but that's going to square it anyway. So plus, and on this one we'll do negative 10 over 2, and it gets squared. So let's see. X squared minus 10x, negative 10 divided by 2 is negative 5 all squared. So we're adding here negative 5, it's squared, which equals negative 4 plus negative 5 squared. So we've got a case here of d is equal to negative 5. That's significant because remember we're following the pattern of x minus d in this case, all squared, equals x squared minus 2dx plus d squared. We had a negative coincided with that negative, which makes that a negative. All right, simplifying a little further. My left side is the perfect square trinomial, okay? So it factors into x minus 5, and it's all squared, and this is negative 4 plus negative 5 squared, which is negative 4 plus 25, which is 21. We now need to square root both sides, all right? I'm not going to put a square root around this one. I'm just going to remove the square, x minus 5, but I will do plus or minus square root 21 on this side. So I've square rooted both sides. And move the 5 over. 5 plus or minus the square root of 21, so those are our roots. X equals 5 plus root 21, and x equals 5 minus root 21. Got them. Okay, let's do one more example in this video. And notice we are always checking for coefficient 1 on the x squared term, which we do not have this time. So we need to divide through by -2. Divide through every term by 2. Because this will then, that'll be over 2, that's going over 2, that's going over 2, and that's going over 2, okay? So it becomes x squared plus 6x minus 13 equals 0. All right, we have leading coefficient 1, and now we can finish the process of completing the square. These two terms stay here. -13 goes over, right? So we've got x squared plus 6x. Leave a little gap for a moment. Move the 13 over, becomes positive. We want to find our d, all right? D is equal to 6 over 2. So it's 3. So it's plus 3 squared plus 3 squared, okay? This means we've got x, oh, we can do the square now. It's x plus 3, all squared equals 13 plus 9. 13 plus 9, 22. Square root both sides. X plus 3 plus or minus the square root of 22. Move the 3 over. X equals -3 plus or minus the square root of 22. Done. Roots. We have x equal to -3 plus root 22, and x equals -3 minus root 22. And there they are. Thank you for watching.